The phone rings. It's the call you never want. Someone you love is in danger, and they are a world away. Every part of you screams, I need to be there. Now. In that moment, you don't care about physics or speed limits. You only care about closing the distance. You feel this raw, primal urgency, a desperate need to tear a hole in the map and just arrive. So let's ask the question that primal feeling demands, can we? Can we ever get there faster than light? It sounds like an engineering problem, a question about engines and fuel. But it's not. It's a question about the source code of reality itself. It's about the logical integrity of cause and effect, the very arrow of time that allows a memory to form, a choice to have weight, a story to have a beginning, middle, and end. Because if the effect can outrun the cause, if you can arrive before you even left, then everything we are, every choice we've ever made, unravels into meaningless chaos. Tonight, we open the books. We run the science audit on humanity's deepest yearning, warp speed. We're going to inspect the blueprints for warp bubbles. We're going to stress test the schematics for wormholes. And then, we're going to ask the universe's chief financial officers, the keepers of the energy conditions, if any of it at all, actually balances the books. This is not just a tour of speculation, this is a forensic investigation into the laws of the possible. First, let's establish the law of the land. Our universe has a speed limit. It's not written on a sign, it's woven into the geometry of spacetime itself. Einstein's special relativity makes it devastatingly simple. Here, in your local neighborhood of space, nothing with mass can ever hit the speed of light, let alone surpass it. For light, it's the ultimate velocity. For you, it's an infinite horizon. As you accelerate closer to the speed of light, time slows down for you, your mass increases, and the energy required for the next little push gets bigger and bigger, approaching infinity. You can never take that final step. Think of it this way. Every moment of your life creates a light cone pointing into the future. It's a four-dimensional cone whose boundaries are expanding outwards at the speed of light. Anything you could ever hope to touch, influence, or travel to lies inside that cone. Everything outside it is, for now, absolutely and totally inaccessible. The speed of light is the wall of that cone. Traveling faster than light isn't about building a faster engine. It's about finding a way to puncture or step outside that fundamental cone of causality. But notice that sneaky little word I used. Locally. That one word is the loophole, the crack in the door where all the dreams of warp drive come rushing in. Because while you can't outrun a light beam through space, space itself can do whatever it damn well pleases. It can stretch, it can shrink, it can warp. Think of an ant on a rubber rope. The ant has a top speed, a hard limit to how fast its tiny legs can move across the rubber. But if you grab both ends of the rope and stretch it, that ant can be carried away from you far faster than its legs could ever manage. The ant isn't breaking its local speed limit. It's still just scurrying along on its patch of rubber. The road itself is just rewriting the rules of distance. This is precisely what the universe does. We see distant galaxies receding from us faster than the speed of light, not because they are flying through space, but because the space between us is expanding. They are not breaking any laws, and neither would a warp drive. That stretching and bending is the heart of Einstein's general relativity, summed up in one of the most powerful equations ever conceived. On one side, you have geometry, the curvature of spacetime. On the other side, you have matter and energy. He basically said, the universe has a divine spreadsheet. One column lists everything that exists, stars, planets, light, pressure, momentum, you, and the other column has the mandatory instructions for how spacetime must curve in response. The contents of the universe tell spacetime how to bend, and the bending of spacetime tells the contents how to move. It's a sublime cosmic dance, and we see it in the orbit of Mercury, in the lensing of distant galaxies, in the spiraling chirp of merging black holes. But any good system, any stable system, needs rules. You can't just put whatever you want into that spreadsheet. You can't just write a check that your energy account can't cash. So physics came up with a set of cosmic guardrails, reality's safety inspectors. They're called the energy conditions. They aren't fundamental laws like gravity, but rather a set of reasonable assumptions about how matter and energy should behave. If you want to build a warp drive, you have to get past these auditors. So let's meet them. First up is the weak energy condition, the WEC. Think of it as the no negative gas rule. It says that for any real, honest observer flying through space, the density of energy you measure can never be negative. Your fuel tank can read full, it can read half full, it can read empty, but it can never, ever read less than empty. It's the most basic sanity check. How can you have less than nothing? It sounds absurd, but violating this is step 1 on the road to exotic physics. Next is the guardrail for light itself, the null energy condition, or NEC. This is the no-toll refund rule. Along any path a light ray takes, the energy can't be negative. A light beam travels for free, its energy toll is 0, but the universe can never pay light to take a shortcut. Violating this would be like light finding a magical downhill slope in the fabric of reality itself, a path that actively propels it forward. The NEC is the weakest and most crucial of the conditions. As we'll see, breaking this rule is the key to both warp drives and wormholes. Then we have the dominant energy condition. This is the cosmic traffic cop. It says that energy and information should flow at, or slower than, the speed of light. An observer can't measure an energy current moving faster than light. It's a rule for sensible cause and effect flow, ensuring a cause can't be outrun by its own wake. And finally, there was the strong energy condition, the SEC. It was the chief architect's rule, and it basically said that gravity, on the whole, should always be attractive. Matter should pull other matter together. It should focus paths like a lens. The SEC was the foundation for proving that the universe must have begun in a Big Bang singularity. But then, in 1998, we looked out into the cosmos and found a shocking surprise: dark energy. An unknown force, an anti-gravity push on a cosmic scale, accelerating the expansion of the universe. This condition is violated every single second on the largest scales across the entire cosmos. So if a universal rule can be broken, why not the others? Is the audit over? Are warp drives back on the table? Not so fast. The dark energy violation is incredibly diffuse, a tiny energy spread out over vast cosmic voids. Warp drives need a violation that is massive, concentrated, and precisely controlled. The other conditions matter because when you combine them with the fundamental laws of geometry, they prove some incredible things. They prove that black hole horizons can only grow. They prove that under normal conditions, singularities are inevitable. And they prove, critically, that without some serious funny business, stable tunnels through spacetime, wormholes, should slam shut instantly. Basically, if energy behaves itself, there are no free shortcuts. But then, quantum mechanics enters the chat, and it loves nothing more than funny business. In the quantum world, empty space is not empty. It's a boiling, foaming chaos of virtual particles flickering in and out of existence for moments too brief to measure directly. It's the quantum foam, a constant hum of energy even in the most perfect vacuum. But what if you could tame that foam? Picture this: two massive, perfectly flat, uncharged mirrors in the vacuum of deep space. You bring them incredibly close together, so close, they're only micrometers apart. Suddenly, the space between the plates is no longer the same as the space outside. The tiny gap acts as a filter. It prevents longer wavelength virtual particles from popping into existence there. They simply don't fit. But outside the plates? The full, chaotic quantum foam is still raging, with particles of all wavelengths pushing and pulling. This creates an imbalance. There is more quantum energy pressure pushing on the outside of the plates than on the inside. The result is a real, measurable force pushing the plates together. This is the Casimir effect, and it has been experimentally verified. That region between the plates, the one with less quantum foam than the vacuum around it, behaves, for all intents and purposes, like a region with negative energy density. We found it. The gas tank with less than empty. The loophole. So, is this our warp fuel? Is this the key? Not so fast. The universe, it turns out, has auditors for its quantum books too. They're called the Quantum Energy Inequalities. And they are the universe's loan sharks. They say, sure, you can have a little dip of negative energy. You can borrow it from the vacuum. But you have to pay it back, immediately, with interest, a larger amount of positive energy right next to it or right after it. You can borrow a tiny bit, for a tiny amount of time, in a tiny space. The more negative energy you try to create, or the longer you try to sustain it, the faster and more violently you have to pay it back with an even bigger burst of positive energy. The universe allows for tiny, fleeting energy debts, but it never lets you open a stable, macroscopic line of credit. Okay. We have our rules. The speed limit is local. Space can be bent. But bending it in the exotic ways needed for a shortcut requires exotic fuel, negative energy, that the universe rations like a cosmic miser. With that background, let's finally audit the dream. First up, the Alcubierre warp drive. The idea, proposed by physicist Miguel Alcubierre in 1994, is breathtakingly elegant. Don't break the speed limit. Just change the road. The drive doesn't propel a ship through space. It leaves the ship in a perfectly calm, flat bubble of spacetime where it feels no acceleration at all. Instead, the drive radically warps the space around the bubble. It creates a powerful wave that compresses spacetime in the front and violently expands spacetime in the back. You're on that airport moving walkway again. You're strolling along at a leisurely pace inside your bubble. But the walkway itself, the fabric of spacetime, is what's moving at ludicrous speed. Relative to a distant star, your bubble could cross a galaxy in an afternoon. The perfect loophole. So, what's the catch? Oh, there are always catches, and they are monumental. First, the bill arrives. To make this work, the Alcubierre drive requires a belt, a ring of that hyperexotic negative energy density. How much? The original calculations suggested you'd need the energy equivalent of the entire planet Jupiter converted into this negative form, and squeezed into a bubble wall thinner than a proton. More modern, optimized designs have gotten it down to perhaps the mass of a large asteroid. But let's be clear what that means. We are talking about converting every single atom of a celestial body into pure, stable, controllable negative energy. Humanity's entire yearly energy consumption is a rounding error on a rounding error compared to this. It's not just a technological challenge, it's a thermodynamic nightmare. Second, what even is this stuff? Negative energy density implies negative mass. Imagine a billiard ball made of this material. According to general relativity, it would fall up. It would have anti-gravity. If you tried to push it, it would accelerate back towards you. It would defy every physical intuition we have. We've never seen such a substance. We have no idea how to manufacture it, let alone stabilize and shape it with the godlike precision the drive requires. But let's say you do it. You solve the energy problem. You invent exotic matter. The design has even more fatal flaws. The front and back of the warp bubble create event horizons, just like a black hole. This means the pilot inside the bubble is causally disconnected from the outside world. You can't see what's in front of you. Worse, you can't send a signal to the front of the bubble to tell it to stop or turn. You have to pre-program the entire journey. You are literally firing yourself across the cosmos blind at 1,000 times the speed of light, hoping you don't hit anything. But it gets even worse. That leading edge of the bubble would act like a cosmic snowplow, scooping up stray particles, interstellar dust, even photons of the cosmic microwave background. But because of the extreme warping of spacetime, these particles would be blue-shifted into super high-energy gamma rays. So you're not just flying blind, you're riding behind a constantly intensifying wavefront of pure death radiation. And the final, catastrophic punchline: what happens when you finally arrive at your destination and turn the drive off? That entire wavefront of accumulated energy, gathered over your entire light-year journey, is unleashed in a single, directed, cataclysmic blast that would vaporize anything and everything in your path. You might get to your loved one's planet faster than light, but you would annihilate that planet and its entire solar system upon arrival. Verdict on the Alcubierre drive: a beautiful idea that reality stamps with a big red: unstable, impractical, and catastrophically lethal. Alright, so moving the road is a death trap. What about taking a shortcut? Let's audit the traversable wormhole, the Einstein-Rosen bridge. This isn't about speed, it's about topology. Picture spacetime as a giant sheet of paper. Your home is point A, and a distant star is point B. To get there, you have to crawl all the way across the paper. It takes forever. A wormhole is like folding the paper over on itself so A and B are touching, and then punching a pencil through. The distance to the pencil, the wormhole, is tiny. You step through a door in your living room and emerge on Mars. We know solutions for wormholes exist in the mathematics of general relativity. But there's a problem: in their natural state, they are suicidally unstable. The moment a single particle of light tries to go through, its energy causes the throat to gravitationally collapse into a singularity faster than the light can make it across. It slams shut before it can be used. So how do you prop it open? Remember the no-toe refund rule, the null energy condition? It says that light rays tend to focus, to converge. Gravity is a focusing lens. To hold a wormhole throat open, you need to make the light rays that pass through it diverge, to defocus. You have to thread the tunnel with matter that has a massive anti-gravitational effect. You need to violate the NEC. You need a huge supply of our old friend, exotic, negative energy. The universe's security policy rears its head again. It's a principle called topological censorship. It basically states that, as long as the sensible energy conditions hold on average, the universe forbids you from seeing or using any non-trivial topological structures like wormholes. It hides its shortcuts to protect causality. To open one, you have to break the rules, and break them in a big, stable, sustained way. And the quantum energy inequalities, the universe's loan sharks, are standing right there, waiting to collect their debt with interest the moment you try. Verdict: the price of admission for a wormhole ticket appears to be a form of matter that the universe simply refuses to put on the market in any usable quantity. There are whispers on the frontier of physics, ideas so beautiful they feel like they should be true. The ER equals EPR conjecture, for instance, suggests that every pair of entangled particles, our spooky action at a distance, is secretly connected by a microscopic, non-traversable wormhole. What does that mean? Imagine you have two quantum coins. They are linked, entangled. If one lands heads, you instantly know the other is tails, even if it's in another galaxy. ER equals EPR proposes this spooky link isn't just an abstract correlation, it's a tiny, physical tunnel through spacetime. This hints that the very fabric of spacetime itself might be stitched together from the threads of quantum information. It's a gorgeous concept. But when you ask, can I send a message through that stitch? Can I walk through it? The audit comes back with the same result. You can't. It's like having a phone line, not a hallway. Information about the connection exists, but it's not a path you can traverse. To open it up would, once again, require feeding it an impossible diet of negative energy. Every path circles back to that same brick wall. So after all this, let's ask the most important question: why? Why is the universe so stingy? Why does it guard the speed of light so ferociously? The answer has nothing to do with speed. It has everything to do with sanity. With cause and effect. Imagine you did it. You found a way to travel or send a message into the past. This isn't just a fun thought experiment, it's a logical bomb that shatters reality. You're familiar with the grandfather paradox. You go back in time and accidentally prevent your own grandfather from meeting your grandmother. You are never born. But if you were never born, you could never have built the time machine to go back in the first place. Your action erased its own cause. It's a contradiction, a 404 error in the source code of the universe. Think about the story with no author. You receive a schematic for a time machine from the future. You build it, and as your final act, you send that same schematic back to your past self. The machine exists. The information to build it exists. But where did it come from? It has no origin. Causality isn't just an abstract rule for physics. It is the spine of narrative. It's what allows a memory to be a memory of something that happened, and a choice to be a choice with consequences. Your identity, your sense of self, is a story you tell yourself built on an unbroken chain of cause and effect. Break that chain, allow for time loops and paradoxes, and the concept of you dissolves into meaningless, contradictory noise. The speed of light isn't just a speed limit for matter. It's a firewall that protects the integrity of time itself. So what is the final verdict of our audit? Warp drives and traversable wormholes look beautiful and permissible on the flexible chalkboards of geometry. But when the energy ledger is opened, they demand a form of payment, sustained, controllable negative energy, that quantum mechanics only issues as microscopic, fleeting IOUs. Horrendous instabilities, lethal radiation, and the watchful eyes of causality turn the dream into a mirage. Impossible in physics rarely means a door is locked and bolted. It just means the price of the key is higher than you can currently imagine paying. The universe is not cruel, it is just a very, very precise accountant. And perhaps that's for the best. Our desire to outrun light was never about physics. It was about connection. About erasing the painful distances that separate us. About getting there in time. And physics has an honest answer for that: connection is possible. Not by breaking the law, but by honoring it with ever more clever accounting. Maybe one day, through quantum repeaters that teleport information, or space-time engineering that respects every rule in the book, we will find a way to make the universe a smaller place without breaking it in the process. The story of reality is written in a language of unbreakable rules and astonishing loopholes. If we could send a single, one-word message to ourselves exactly 1 year in the past, what word would you send? Let me know in the comments below. I'm fascinated to see what you choose. And if you want to continue auditing the very foundations of what's real, exploring the lines between what is known, what is possible, and what is pure fantasy, make sure to subscribe and turn on notifications. We run this audit line by line. Now, the journey doesn't end here. Up next is a video that dives into the single most baffling mystery our audit has ever uncovered, waiting for you right there on the end screen. Click it, and let's keep digging. See you there.